Hello everyone. This is going to give you a little bit more information on what's going on with Lab 3. Specifically, it's going to talk a little bit more about that math involved in calibrating your microscope. So I'm going to go ahead and pull up that Chrome tab, and then we're going to jump into calibration factors. So this video above here does a really good job. The explanation here below breaks it down a little bit differently. So I'm going to sort of explain that gap between breaking down the video and the example used here. So scrolling down, this bottom set of markings, that's actually your stage micrometer. That's a really tiny ruler built into a microscope. So from here on out, I'm going to refer to it as the ruler. And then here up top, that's going to be just 100 tick marks. So the way the eyepiece micrometer works, it fits into the objective lenses of the microscope. And essentially, there are 100 of these tick marks here in this example, and it doesn't change depending upon the magnification. So if you're looking at something under 10x magnification, there's 100 across. 100 of these eyepiece micrometer ocular units across. If you look at it at the 20x, there's 100 across. If you look at it at the 40x, there's 100 across. No matter what your magnification, it's always the same amount of ocular units across. And so that's not super helpful for trying to actually get an absolute like measurement. And so the conversion factors allow you to use this microscope, use a ruler built into the microscope to actually compare how many actual physical the distance between these tick marks at any given objective magnification. So here, the ruler we have built into the slide, we know it's 0.01 millimeters from each of these individual tick marks. So the way rulers work is that these largest tick marks basically represent your largest full unit, and these sort of a little bit smaller tick marks represent half of a unit, and then there's 10 individual smaller units in one full unit. So the halfway represents 5 smaller units. So here 0.01 means between each tick mark there's 0.01 millimeters. So if we count it up, 0.01, 0.02, 0.03, 0.04, 0.05, which represents essentially a half unit, 0.06, 0.07, 0.08, 0.09, and then that represents 0.1. So these largest tick marks are going to be 0.1 millimeters across, so 0.1, 0.2, so 0.1, 0.2, 0.3, 0.4, 0.5, and then 0.6. And then we kind of get cut off after that. So if we count how many tick marks there are, so matching up our ruler, we want to see where one of those major tick marks line up on our ruler with one of the major tick marks in the oculus, the ocular unit, the eyepiece micrometer. So here, the first time one of these major tick marks line up is actually at 30 ocular units. So we know that there's, if we count all the way across, 20 ocular units match up with 30, so 20 of our 20 tick marks on our ruler match up with 30 ocular units. So we know that on our ruler, each of these tick marks are 0.01 millimeters across. So if we just multiply 0.01 by the number of tick marks, then that gives us 0.01 times 20. So they call these tick marks stage units. So the bottom are the stage units, and on the top are the ocular units. So these stage units, we do know the actual distance between them, but the ocular units, we don't. So if there's 20 stage units make up 30 ocular units, then how many stage units make up one ocular unit? So that essentially is answering the question, how far apart are the ocular units? Well, we use this ruler to figure it out. So the 20 stage units across, we'll multiply that by 0.01, which is how far apart they are on this ruler, and that gives us 0.2 millimeters. What that means is we had counted up before, but 0.1 and then 0.2. So from major tick mark to another major tick mark. So 0.2 millimeters matches up with these 30 ocular units. So if we want to figure out how many millimeters are in one ocular unit, then we essentially divide that distance, that 0.2 millimeters, by 30. And what that means is 0.00067 millimeters are in one ocular unit. So here it's really hard to tell, but between 0 and 1, so this is 0 to 10, there's 10 here, ocular units, and there's 5 ocular units here. So between 0 and 1 in real life, that distance is 0.0067 millimeters. And so that only applies to the objective lens we're using here. So for the other objective lenses, we'll have to do these calculations again. So looking at these quiz questions, so 60x objective lens is going to be the one we're using for this problem. And then it says, again, each on a stage micrometer, those stage units, so the units on your ruler are going to be 0.01 millimeters across. And so we count 45 of those stage units. So 45 times 0.01 will get us, let me scroll back up. So up here, we counted 30, but for this new problem, imagine this major tick mark lining up at 45. So to find out what that major distance is, you'll have that 0.01 times your 45 stage units. So the lines match up at, let me see, 0.01 times 45. They line up at 0.45. And so 0.45 millimeters is 30 ocular units. So how many millimeters are for one ocular unit? Well, it will be that 0.45 divided by 30, which will be 0.015. And that indeed is an answer. So going to this next quiz question. So what must be calibrated at each objective? So remember, your stage micrometer, that's the ruler built into the slide, and that is going to always have the same absolute, well, it's a ruler, so that's what you're going to be using to measure. But the ocular micrometer, those ocular units, they don't have a real distance between them. It's sort of that you can use. You have to use a conversion factor. So you have to calibrate them. So it's going to be the ocular micrometer that needs to be calibrated, because the stage micrometer is what you're using to calibrate, the ocular micrometer. All right, is the ratio of the calibration factor, so the ratio for the calculation, the calibration factor, is that stage units divided by ocular units? No. So those stage units in this example above here, we counted 20. we need to multiply that by that 0.01 to get that actual distance. So the answer would not be stage unit divided by ocular units. It would be stage units times that actual that distance, that scale here, divided by ocular units. So here, this conversion factor, that is 0.2 came from that 20 stage units times that 0.01 like distance scale. So the answer to that would be false. And then here you calculate the calibration factor using the 10x objective lens. This calibration factor can be used with any objective. The answer is no, because those ocular units across are always going to be 100 across. Whereas in reality, if you use the objective lens to zoom in to the stage micrometer, the ruler in the microscope, you'll see fewer and fewer of these tick marks as you zoom in onto your ruler. But the ocular units, the eyepiece micrometer, will always have 100 across. All right, and check our answers. And we have 20 out of 20. So hope that helped. And I'll see you all in the next video.